Awesome. Okay. So this is also project that's been ongoing for a while, with ups and downs along the way. So curious where we landed now, and we'll see what we might have as options for next steps. But yeah, this is a project with Dr. Carlos Martinez Mori now at in Colorado, at UC Denver, in math and statistics. Was originally here, and yeah, he's a co-instructor for this. So please.
Yeah, as Patrick said, this was brought up by Carlos Martinez Mori, and he came to us with this idea of how we can use game theory potentially to simulate urban dynamics.
So as some background for motivation for our project, we're interested in how like infrastructure and building amenities and stuff affects how people move around an area. So for designers and planners, they need to keep this in mind because it'll change the like income and socioeconomic standing of the people who live there. As we've all heard of gentrification, which is when like higher income people replace the lower income people originally in the area.
Mhm.
Extended. So our project, we are studying specifically the Atlanta Beltline with those motivations in mind. So the Atlanta Beltline is 22 miles of biking, hiking, and transit stuff around Atlanta. The purple is where the Atlanta Beltline is. So this has been an ongoing construction for quite a while. So it's a good research topic because we have a lot of data previously, but it's still ongoing. So we can attempt to predict what the end results will be in terms of demographics. And there's lots of data and research that have already been done on it.
So our models and our approaches, we have like analytical models where we start from theory, we have our system, how it should work, the variables and the relationships between them, and the empirical models, which starts from the data, sees like how the relationships between the data and like the patterns that best explains these results. And so this is what we focus on, agent-based learning models, and the approaches that we start off with are no regret dynamics, push-pull cost models, and the gravity models. And the very first one that we started off with, our legacy model, the no regret. So basically the variables it looked at was the affordability, crowding, community fit, amenities, beltline effect. And like these are some of the equations that we use for no regret. However, no regret was like not very effective, so we used different approaches.
The reason why we use no regret learning is because the agents are able to learn from their own behavior, meaning as opposed to other agent-based models where we define some stochastic behavior for the agents and the model becomes deterministic. This model allows the agents to act, and after they act, they also then change their future decisions based on the results of their actions. And the reason why this is important is because the beltline is always changing, and the way people move, their decision making might change over time, as opposed to just having the same decision making factors throughout multiple years. And so ideally, the end result of this model replicates the data that we see from the census. Which counties, which census tracts in Georgia have which incomes, which populations, and by doing so, we're able to say, okay, after the beltline is completed, what might the social economic distribution look like? And this might help urban planners decide where to put which amenities, which parts of the beltline to expand, etc. And just as an idea of how we kind of get our data, this is the amenities in Georgia, which is pulled from OpenStreetMap. And as you can see, certain areas of Georgia, especially Atlanta, the city area, also some other cities, if you're familiar with Georgia, like the DeKalb or Duluth, are definitely have higher amenity rates. For that reason, we say that these tracks are more attractive. And we do some data processing because, as in the other projects, OpenStreetMap is open sourced. And so for that, certain tracks might be missing data or have underreported data. And so we use Green Continuity model to kind of fill in those gaps with information from the surrounding areas. And this just shows how the agents learn over time. In the beginning of the model, the agents behave rather stochastically, but as time goes on, and they learn which tracks are beneficial to them, which tracks are less desirable, the rate of change decreases such that a behavior, an observable behavior emerges from that. We can say, okay, this behavior should be approximately what we see in the real world. And just a brief description of our other models which we're using, both of which are commonly used in the urban planning space. One of them is push-pull. And the intuition behind this is that, there are always going to be benefits to staying where you are. There are going to be benefits to move to other tracks. So how do we balance this? Well, we take into those various factors, like we said, amenity counts, population density, how similar an agent's income is to the track that it's in. And we say we get a probability of moving to a certain track or something else. So we consider both origin, desirability, as well as the destination desirability. As you can see, if a tract has a cost of staying at 0.9, which is bad conditions, and if a tract has a cost of 0.2, which is, for example, have good amenities, or it might not be overpopulated or underpopulated, like they move there. The gravity model, on the other hand, is a little different because it divides this process into two steps. The first step is deciding whether to move or stay. So this is different because regardless of the destination's attractiveness, it says, okay, are we leaving the track that we're in, or are we staying here? And we want this model because we thought that affordability was the main driving factor behind moving in the real world. So if someone lives somewhere which is pretty affordable, it's very unlikely that they'll move out of it. If it's unaffordable, they'll almost certainly move out of it. And so we say they will move if the track is unaffordable. And if that's the case, then we look at the desirability of destinations and decide, okay, now that we know they're moving, which destination will they go to? And these are just a few of the factors I'm include, which, amenities, the socioeconomic fits, how close it is to the beltline. That's important because, this whole project is seeing the effects of the beltline. So we're saying if it's close to the beltline, the tract is more attractive. Population mass, we say that if a tract is underpopulated, then it's less desirable, because if it were desirable, then more people would move there. And then distance region, of course, people are more likely to move somewhere nearby as opposed to somewhere 100 miles away. And yeah, this is just the similar formula for the push-pull model. It's the same factors. We just show that we compute a cost for staying and a cost for leaving. So that's just showing we consider the origin and destination in that model.
Which of these are we learning, these factors there?
Sorry?
Which of those, can you just highlight what are we learning here? I mean, the cost function is something that we estimate, but W's are weights. Are these the ones that we're learning?
Right.
Yeah.
So
what are the other things? Just roughly.
Yeah, so very high level, people value different things differently. Someone might value the people in the lab might value economic fit more than they criticize distance. And so we have these weights for each factor, and we acquire the values for these weights by looking at the census data and saying, okay, compared to the data reported by the census, which values for weights replicates the census data, meaning which values for the weights do we observe in the real world? And by using a calibration model for this, we run our simulation and we acquire the weights, and we use the values for these weights to run our model in the future. And so, for example, affordability the weight for that was very high. So it might be 0.6 compared to if the beltline score was at 0.2. That means the affordability of a tract has a greater effect on the decision-making process of whether to leave or stay than, say, the beltline might. Yeah, and as you can see, the difference from the original model, the push-pull model is still no grid based, but uses, consistent origin and the destination. And like I said, the gravity model, it divides into two steps: if it leave or stay, and if it leaves, where should it go? It's just a summary of our gravity model. Where we stay in the previous destination.
So our model right now is already pretty complex, but there are a few things that we want to tweak or add. Right now, the main thing is, like we were saying, all of the different models to approach agent-based behavior and how we can model how people are moving around. And then kind of connected to that is refining the cost function. So we experimented with different types of cost functions like different structures of cost functions to try and see if any of them could give us desirable results. And that's something that we want to continue doing. Another thing that we could look at is different calibration approaches. So we've used PSO and SOVOL sensitivity analysis, and then more recently we've looked at RBF opt and PyGoBQA to see like which of these calibration models. They're all black box calibration models where we can put in like our input parameters, like maybe the weights of the cost function, to try and find out what weights would be best for the simulation when comparing to the census data, as Matthew was talking about earlier. And then also just to validate the models, yeah, and on those years, 2013 to 2023 is what we've been working with, because those were kind of the years, I think that kind of aligns with when the Beltline was being built. Another thing is extending the model. This would probably come later. We had already planned on making the decision maker agent, but we put that on pause for now. But the decision maker agent would basically be its own agent in addition to the existing agents that can change like the housing capacities of each of the census tracts. So it would act as kind of like a policymaker that would affect how many people can move to a certain tract, and that could be in addition to the model. Another thing is horizontal scaling. So right now we're focusing a lot on vertical scaling, and that's like density caps of certain places, and I can maybe like add more amenities or increase the effectiveness of the Beltline. But there's also another aspect, which is horizontal scaling, which could be like expanding the Beltline and seeing how that can affect different neighborhoods. And then we also have been working on a draft for a paper, and right now,
Why are you laughing?
there's just a lot that's gone into this, but before like recent developments, we kind of had a different idea of what we wanted to do with the paper. But now we're kind of leaning into this idea of we can compare these three behavioral frameworks. So the legacy no regret model that we had, and then these new push pull and gravity models, and then kind of compare and see what the strengths and weaknesses of each of those are and how they can model human behavior. So like this is just an example of one inference we can make, is that structured human behavior assumptions, like what happens in the gravity model, can outperform unconstrained learning through neural dynamics. And like I said before, then we would use the best performing model to simulate vertical scaling policy interventions. Some additions to the paper that we can have is like we have figures for model comparison, calibration, and policy impact, and we already have the architecture to build those visualizations. But as soon as we get the model running and find a good model that we're satisfied with, then we can go ahead and run these visualizations. And then we would also have to validate the data as well on different types of distributions. And then kind of the main thing is that we want to answer is like, what do these models teach us about how people can make housing decisions? And that's like the direction that we want to go with the paper in the future, which is different than what we have been planning on. That's kind of it. So we can open up to any questions that you guys might have.